Hello, good evening. Tonight we've got a really special set of, an exhibition set of talks about artificial intelligence and how it may affect the world of lighting design in particular. And to introduce the whole evening, I would like to bring on Florence Lam, who's the Head and Director of Global Lighting Design at Arup. Thank you.
So thank you, Peter, and welcome everyone this evening to come to Arup for this event. And I'm also always apprehensive about screen and slide that moves. So I'm just trying to hopefully that it's going to work. It's more than a 1 gig big. Okay, the world of lighting has been rapidly evolving, and we all know LED has been hailed as the almighty breakthrough. Not only has been playing a very important role in illuminating our lives, sustaining our health and well-being, but this technology has also been a key and pivotal in the convergence of lighting, media, and digital connectivity. However, the technological revolution is not just about LED. The revolution that is going to engulf our lighting industry is much more beyond the LED. We are now in the brink of the fourth industrial revolution that is fundamentally going to transform our life, the way how we learn, how we live, how we work, and how we relate to each other. And this revolution is going to be powered by artificial intelligence and big data, fueling the deep learning of machines. And that's why we are here this evening to explore the very questions, and a question that me and my colleagues has been wondering over the last 12, 18 months at Arup. And let's watch this video.
The question was like, will we be replaced by a computer?
We're using AI as far as possible. It's quite embryonic the way you can use it. Optimizing infrastructure, having better control of how things are going to perform and understand when they're going to break down. You can see it being a huge step change in productivity across reams of business, across reams of industry.
AI to me is a tool that helps with the design, make it more efficient. Because normally when you explore or doing the research, you kind of have a clue of what you're trying to look into, and almost that's defined the realm of areas that you're going to look into. But whereas when you're working with something of AI and machine learning, that actually poses you a lot wider possibilities of what you should be looking at.
I can see a shift in the roles, and I don't see a threat to people. We could have somebody directing a machine for us to do that work, that fine work, very quickly, very efficiently. That is something that is interesting and is a cooperation between the man and the machine. So you could use a machine to spit out ideas quickly for you, and then we will look at more complex, more interesting problems.
You can almost do an activity just identifying where you've got the data to make artificial intelligence useful. It enables you to predict things that formerly you couldn't analyze. Being able to access other variables such as human behavior or well-being, things that rely on large data sets, presents more opportunities for better design. I think in the future, everything that can be codified will be, so that it can be done more efficiently. I think that there's a lot of opportunities for doing stuff better with AI.
I see the way that how AI can move even faster is the connection of community. That the designers who are just used to work in a certain way, engineers work in a certain way, be open-minded about this new set of tools or new personality that is going to come into the design process, and how to embrace it and be really open.
We need to change the way we work, and to do that, if we are still able, we need to change our skill set. How do you know about big data? How can you connect a database to something else? How can you make sense of all these little bricks of science and put them together in something that is useful? That is the type of skill that we need. We need people who will tell me like, oh, I don't know any software, but I can write one for you.
Researchers also started looking at the consciousness of AI and machines. We need to sort of stay really clear ourselves what sort of attitude we're talking about, what sort of consciousness. I see machines like a child. You bring a child up, you teach a child something or value, and the child is brought up in a certain way. So with a machine, you can teach them values in a way of some kind of logic.
Maybe we should look at the process of design and look at the tasks that are contained that can be done better with the machine helping. They're not trying to find, to squeeze the machine into a human, which is not what we would like to do. I think it's pointless. A human have got abilities machine doesn't have, and the other way around. So it's best to look at what the machine can excel and then try to find the right task.
There's been certain step changes, during the course of human history where a new technology's come into play and it's totally changed the way that we do things. This seems to be the start of one of those, and certainly that lends itself to being defined as a disruptive technology.
Okay, so this evening, I hope to open a dialogue on the potential meaning and impact of AI to the future of our lighting profession, from research to design, and then from manufacturing to operation. There'll be 5 speakers tonight, 2 talks, 3 provocations, to get us into the AI mindset. Almost certainly, these talks will be slightly away from your day-to-day work, so I ask you to step out of your comfort zone and then to explore something new this evening. Focus on what might be rather than what it is. Then I will encourage you to spark a debate after this, in this talk, and then later perhaps over drink or food with your peers, what you have heard and the broader role that our profession may play in this digital space. So first off, I'd like to invite Giulio Antonutto, my colleague. He is lighting design leaders with us for over 15 years. His expertise areas range from lighting for broadcast, product design, day lighting, and city planning. He has extensive experience in the development of advanced computational optimization design, parametric and generative design tools. Giulio has worked on a wide range of high-profile projects, and some of his favorites include the more recent award-winning, the Winton Gallery at the Science Museum, the London Aquatic Centre with Zaha the Architects, and Lorenzo Piano's new pavilion at the Kimball Museum in Fort Worth in the US. So without ado, can I invite Giulio? Yeah.
It's really me. Luckily, I didn't have the right chair today. It's the good chair, so good. Okay, so this is about the future and probably the next future. And what I want to show you is like a parallel between different type of industries and actually the artistic part of lighting, in a sense, and what machine learning and artificial intelligence could do for us and what maybe cannot do for us. It's a provocation, let's say. Let's follow me. It's an adventure. So if we look at the future and think about machine learning and intelligent machine, then we have obviously to start from Alan Turing. Yeah, everybody knows Alan Turing. They made a movie like 2 years ago. It's a great mathematician from here who actually resolved a very complex cryptographic problem, which was a war secret. In fact, it was very lately acknowledged as a genius and a great human being because all he did, it was top secret. It's like sometimes projects are confidential, you cannot say anything, and that's it. And also he was very unlucky because at the point in which he lived, the society wasn't ready, and so, embracing everybody as it is now, so he had really a bad life. He was, he died because he suffered from being homosexual. The government actually condemned him for this. It's really bad. Anyway, on the positive side of his life, he was the one who led the Allies against the German machine that is now shown in the museums. There was like a cryptographic machine that was able to hide secret messages from the German soldiers in order to have an advantage over the enemies. So they could say, oh, we are going to invade at 11 o'clock, and nobody could understand the message, then they would do it. And this machine was a mechanical machine, and in order to defeat it, him and other researchers from Poland and other locations in Europe built a computer, essentially a mechanical computer, which at the time was able to resolve a problem which was a very complicated logical problem. And being a very complicated logical problem brought immediately the question, well, if the computer can resolve such a very complex problem, isn't the computer so intelligent as we are, or even more? So who is intelligent, us, the computer, and so on? There wasn't a notion of emotional intelligence at the time. It was just about logic. And the question then was, if the computer can be intelligent, how can we tell whether it is or not human? And how do we measure intelligence? And this was discussed in a paper by Alan Turing, in which it describes the intelligence as something that could be tested with a series of questions. You would compare the answer between an unknown entity and what you expect, being a human answer. And if you cannot detect the difference, then that thing that is telling you something is definitely human and is not a machine. So if the machine can trick a human in looking like human, then definitely the test is passed. And that was the starting point. So machine looking like humans. And now, listen to the whole. If you buy the CD, I recommend, it's really good. Or you can even play, if you know how to play, there is a score just across the road on that white building. You can read it under the canopy. There are all the notes of this. This is like the Art of Fugue by Bach, and Bach is the next big human being that we are going to discuss, because Bach is now acknowledged as being a great composer. Everybody doesn't doubt about that. But when he was alive, he wasn't considered like such a great composer by his peers and his people. It's because he was lost in the past. He was still referring to models that were, in vogue in Renaissance time, like this big contrapuntal music that was in North Germany was really popular for choral works and so on. It was such a complex structure that wasn't really easy to listen to, that wasn't really appealing to the sort of emerging gallant style, so he was a bit out of fashion. But in his doing and referencing to the model, he made most of his art, and he developed such a complex system that is still unmatched. Well, it was matched in recent time, but it's still an example. So if you take a score of Bach and you consider it just as a sequence of graphic elements, you don't know music, for example, and you look at the geometry of the notes, you can recognize patterns, which are, for example, the theme, like the melody, and then an architectural construction on the top of that, where the same phrase is repeated asynchronous to the first one and connects in a very complex structure, and all makes sense harmonically. So it's not just a diagram with nice graphics, but it's something that sounds really nice. It's really good. It's complex. And this theme repeats and repeats, and also, for example, it dilates in time. So the same sequence of notes become much longer and still matches and connects to all the rest. It's like a very complex architecture. So Bach, reference to the past, complex architecture. An architecture, somebody said, that is frozen music. So if you have music and architecture link, for some people, is very clear. There is structure, there is rhythm, there is like element, theme, and so on. Then we can look at that in somebody from Renaissance. So we look at Palladio, for example, and Palladio, very interesting, because for the first time you start putting together almost like a counterpoint in his architecture, where you have like an element which repeats in the facade of the building on several layers. So it's not just the shape of a building, but it's several repetitions of the same element at different scale. So you have like a small portal, then a larger portal, then a hidden portal, then the shape of the building, and so on and so forth. And then Palladio was a model for some, and yet he used model as well, because he took from the Roman, who took from the Greeks. So there is all this story of the human using models and referring to the models. Interestingly enough, if you take Palladio books published, were a very important inspiration for other architects, right here in the UK. For example, this is like Footscray Place by Bexley, sorry, not this one, and it's very similar to La Rotonda in Vicenza. They are very similar buildings, but yet one is newer, the other one is older. It's a reference to a model. There are improvements, there are variations, but still it's human. People did it. and they are great architects. Now we go to human using machine and referring to his own music as a model. This composer from the US is using computer that read his previous composed music to recreate new compositions, because he was a little bit bored of writing music for the TV all the time and spending so much time. He wanted to dedicate more time in creating more interesting compositions for his pleasure and his career. And so he built a software that would read all the composition he wrote and generate a new one as permutation of the existing one. Now, he went even, so you could say maybe he's not a particularly good composer, so his work not so good. But then he went a step further, and he ingested all the music of Bach, Beethoven, Rachmaninoff especially, and so on. And he made a composition out of a computer, where he didn't do anything, the computer did, by creating something new out of a model. So the thing is that I was quite curious about that, and the name is David Cope, and I bought the CD with the music of Bach and the music of Rachmaninoff. And the Bach one, you could tell it looks similar, it sounds similar, but perhaps because it's a MIDI file, which is played by a computer as well as composed by a computer, it's a little bit dry. But the Rachmaninoff one, which is played by a true orchestra, so it's a score written by a computer, and there is a human orchestra playing it, really looks real. I mean, it's incredible. And that makes you think, where does it start and where does it stop the art? Is it the listener or is it just the composer? And is it really truly art, music, or not? I'm not the only one who had this doubt, and obviously I don't want to compare, not even by a little bit. By Douglas Hofstetter, who is a friend of David Cope, was listening to his music, and as a test, as a game, called another professor from the university and said, oh, listen to this music, what do you think? Is it written by a machine? And there was music written by the real person and by the machine. And this non-expert was strict and said, oh, this is really beautiful, oh, this is a bit rubbish. He lost a friend, but he clearly got to the point in which, according to the Turing test, you couldn't tell which one is which. Therefore, the machine really made good music. Therefore, the machine was intelligent. So, you know, reference to a model, intelligence, and so on. If we go fast forward and then to the more recent time, and look at strategic thinking, and then, okay, good, you reference to a model, but what about decision making? Can you then drive a meeting or decide what is the best choice or what you are going to do next for this project? We take Napoleon and you say, can you do like Napoleon? Can you win a battle by knowing where the troops are and then strategically thinking? So, our computers were used quite a bit to entertain, and with video games, typically, they are playing against human. So they represent an opponent. And we win, we lose. So somehow, sometimes they win. Sometimes they only win because they are faster. They can shoot a lot of rockets, and they move randomly right and left, and it's really difficult to follow. So it's a problem about our ability rather than the computer ability to think. But then with the Football Manager on audio cassette, for the first time, well, actually not the first time, but let's say the pop video games, they started to look into strategic thinking and playing soccer. So you could select a good player with the proper skills and spend the right money and then try to win the championship. And then fight against the computer-generated programs and watch your game of the time, Aston Villa, Mansfield. I'm not sure if they are still there, but maybe they are. And that brought to a bigger question, like, see if the computer can do, video games, popular industry was booming, it was the 80s. Then everybody started to think like computer going to war and fighting against the human, or for the human. And then this movie popped by, there was like the Jig guy, a bit cliche with a very nice girlfriend, and then he calls a computer with a phone because he wants to download a video game, and the computer is the computer of the super secret American base that is actually starting to play a nuclear war with him, and is starting to shoot the rockets to the Russians. It's like crazy stuff. The whole point was that at the time, it was 80, they already had this impression that computer would come the day after, and it would be like a disaster, and then, this idea is very old, since the Golem almost in Prague, the same thing, like some human-made terrifying monster. But then it became more real when we look at the poor Kasparov being defeated by Deep Blue, like in the early 90s. I remember the match. It was my hero at chess, and I was very disappointed at the time. But thinking back, he lost 3.5 to 2.5, and every game is 1 point, 0.5 is equal. So he only lost by one match, basically. Otherwise, it would have been the same as the machine. A machine who had like an unlimited number of processors, like super fast, and also machine was trained by 10 grandmasters. So it's like one man against 10 of the best human, plus a supporting computer with like a monster processor, like doing everything. And this guy almost made it, but yet he didn't. So the history now tells that, yes, chess can be done with a computer, much faster, can evaluate much more things than we do. But in reference to a model, yes, because there are the libraries, but is it truly thinking? At the time, he said, no. He said that, in fact, those 10 grandmasters were cheating. They were like trimming off some of the ideas of the computer, saying, okay, this computer is telling you that, a stupid move, let's try that one. And so he said, surely somebody is hidden into the computer and in some way is driving the situation. And he requested the plot of the game from IBM. And IBM said, no, we cannot secret, sorry, don't share that. And they closed all the factory, they made the computer disappear, and there is a movie about it as well, another movie. Nowadays is a different opinion, but at the time was very upset. Then there is another movie, yet another movie, as you know, he keeps going with movies. Bill Bain, Oakland Athletic, this guy basically won, no, didn't win, but got second in the championship by playing statistics with the capability of the players and a very tiny budget. So what he did, he set up the objective function saying, I want to spend very little and I want the most out of my players. So a very good team with very little funds. And by being good in getting the criteria, the feature of the data set, he could beat almost everybody for 18 games in a row, which was incredible. At the end, he didn't win because his budget was tiny. And the year after, everybody copied the system, and they did very similar. So strategic thinking, statistical machine learning, creeping into real problem, for real. So decision-making can be possibly as art, as music, as architecture, treated as a game. So in terms of what we could do in our industry, lighting-wise, so we have parametric design and BIM and so on. We connect everything to a huge database. We can, in theory, measure everything we do. We can spray fixture in a building without having to design because they are just connected to a feature. Yeah, maybe. And we can make very complicated things. We can drive the whole thing with the engine of design optimization. So, for example, you can set up the criteria, and then you can ask the system to evaluate by moving slightly things until you get your criteria satisfied. And, for example, minimum energy consumption or like best uniformity, maximum built environment to meet the BRE standard, well, guidance, I should say, and so on. So, again, you can do it. And one of the methods that I really like is the ant colony optimization. So it's the metaphor from the animal, the ant. So you spray ants towards your goal. Most of them are dispersed, but the ones that go closer to it, they leave a scent, the pheromone, which evaporates after a number of iterations. So the more ants you send, and the more they go towards the goal in the same direction, the more this scent is retained, and the more probability is that they will follow the correct trajectory. After like a lot of them, like in real life, they will reach the objective and eat it. It's another movie as well. It was an AI ant, but a truly biological gigantic ant in the desert of Arizona. It started with a child running away that doesn't talk, is too shocked, and then they discovered that the whole family was eaten by the gigantic ant. But for budget reason, it's a low-budget movie. The monster only appears after half of the movie. It's all like you don't know what's going on. Everybody's screaming, but then one only frame. Optimization, after all. Then, so you have parametric design, design optimization, and then now you can also chunk the large data set, which is the novelty, basically. This machine learning, it's powerful because you can read a lot of data and deal with it in some way. And so you can have this magic data set with all the possible solutions, you chunk it in, and then it will tell you everything and find the best solution for you. So now, how do we deal with learning? Again, if it is about making decisions, it's all a matter of probability and statistics. So some things are statistically true. They are not really that true. They are probable. And so is this machine learning. And some time ago, basically, the answer to the question is that artificial intelligence will design the way we design. It was like, oh yeah, of course, like, you know, it's like all these movies since the 80s. Are you joking? It must be like next June. Like, you know, they told me on TV, everything. Then you update the computer and it breaks, and then you wonder. But anyway, you do wonder. I do wonder. So let's wonder a bit more. This famous diagram, I'm sure everybody's seen it. I saw it for the first time a few years ago, but now it makes more sense. And I felt like that at some point, and it was really exciting. And it's exciting when you start putting machine learning and artificial intelligence in your tools at work. You connect, I don't know, Grasshopper model or MATLAB or Python, everything you want, and then make the machine do stuff for you. And that's pretty cool, and it works. But does it really work? So there is a point in which you realize that it's just statistics. That is not that it's like a magic brain somewhere hidden that will decide things. It's only like statistics. It's 9 times out of 10 something is true. That's it. 9 times out of 10. It's not that something special. And so that it comes with a lot of problems. Problems that are mostly glossed over, ignored by all the propaganda we are subjected to. Like, you know, all the media speaks about how good the machine is, Terminator is coming, and all of that. But imagine a Terminator that 9 times out of 10 makes a decision, and that is the wrong one for him. He will die probably at some point, so no problem. The problem is the bias in the data, overfitting, and then one biggest problem, which is human problem, that sometimes we confuse what is causality and what is just coincidence. For example, like a glorious magazine, like the Daily Mail, I guess, no? They tell you in the summer that if you have a long finger and the other one is shorter, you are more intelligent, or next year you have got more sex appeal, or something like that. That is clearly not causality, but it's just coincidence, because the 3 people they asked to, they had the longer finger, and they decided they were sexy or something. So some people don't understand that, and they will run a very complicated computer model, and then plenty of grasshopper things and so on, and the end result is not going to be very informative, because it's just junk, basically, junk in, junk out. And that's the same with the bias of the data and the overfitting. So, for example, in a recent conference, somebody said actually that here in the UK, we have the best engineers at predicting the weather. And then I thought, oh, shit, you know, that must be true. And then I brought it up, and this is true. I go BBC, and it comes out like this. And I thought, wow, that cannot be that difficult, no? Like, I mean, because they're always the same. Even if one day is different, you got like 90% probability of being right, because that only day is different. The other one are all overcast, so, you know, you don't need to train a machine to do that. So once you realize all of these little glitches, then you start thinking that, yes, the machine can test, can take the data, can suggest options, can do a lot of stuff for us, but only if we have our critical thinking still there. Because if we leave it, drive the design for us completely, without us doing anything, is going to be a disaster. So my personal conclusion at the moment that this is not really the case unless we retain our brains. Thank you.
Thank you, Giulio. So we must retain our brains and watch a lot of movies. That's the conclusion. Okay, so the next speaker is Francesco Anselmo. Francesco is a lighting and interaction designer with our team in London, and he loves exploring how light can shape the experience of a place and influencing people's emotions and stimulating behaviors. His new passion for physical computing has led him to explore how digital technologies can simplify or amplify our interactions with buildings, and to question the words intelligence and smart, what they really means in a context of built environment. I'm not going to mention any of your projects because they're all confidential. So I'll let him just talk about some of the project that is happening to be not confidential. So Francesco, there you go.
Thank you.
Okay. So when we begin working on a design idea, we start describing it with words. And as our thoughts flow, we jot them down, we use adjectives or short sentences or bullet points, creating a written brief, one word after another in one dimension, linearly, with a voice or writing on a notebook. And at some point, we start to visualize these words into images. And we need to add a second dimension. Once we're happy, oops, sorry, that's it. Yeah. So we draw sketches on paper, we define better what we want to achieve, we communicate visually our intentions, we test options, and we refine our design. So once we're happy with it, we crystallize it by making technical diagrams and drawings, and where we use scales, dimensions, and annotations, we create representations of what will be built or manufactured. But even drawings on paper are not enough, and we would have already started making physical or virtual models, exploring in this way the third dimension of our designs. So these geometric models describe and anticipate more closely the final objects or design experience. They make communication easier. They can be used for testing, for detecting geometric problems, for running simulations. And ultimately, they become reality. And this is when the project starts to have a life. And we add a fourth dimension, which is time. So time for a luminaire can obviously mean the light. But in this particular case, it is both varying brightness and moving the luminary space. And the motion can generate patterns of concentrated light, can generate shadow, can focus the light. In this case, over the shards, they can create various effects. And they create a dance of robotic light that slowly reveals the space and starts telling a story in a choreographic composition that is serving the chosen narrative. So the light slowly starts to become a character and shows some traces of being a creature, perhaps even to have an intelligence of its own. So this is when a fifth dimension starts to emerge. And this fifth dimension is behavior. Behavior means designing with interaction in mind, with a palette of infinite possibilities. This is where I think a programmatic and algorithmic approach can positively influence a spatial design, a lighting design, and even a luminaires design. So we've tested this idea, creating an interaction behavior through light in a few projects, and I'm going to show you a few. So we cannot have behavior if we don't have an understanding of what goes on around us. And in this project, for instance, we've created a relationship between 11 locations in London and 11 lights that are part of the installation. This location gather air pollution data from the internet using the London Air real-time dataset created by King's College. And then they translate it to dynamic color that variates the light, lines of light integrated in the architecture of this pavilion. So I like this project because it shows a positive example of connectivity. I also like it because we design and program the behavior of all the lights ourselves. And finally, I like it because it shows how information can be moved to the periphery of a vision, providing still a relevant message, but not asking for undivided attention that our smart devices demand all the time. You see the guy over there looking at it, and maybe the periphery of his vision. That's that little bit of information. So this idea of information at the periphery is quite refreshing, I think, and can possibly slow down the speed of our lives, similarly to when we play. And play is, in fact, another behavioral aspect that we like to explore, in this project. So in this project, the interface to the lighting sculpture is web-based, and it includes a mode to paint colors on the different lighting segments. So we've created the system with open source technologies and the standards of the web, which can also be programmed directly by the people working in the building with a little bit of coding knowledge. And actually, there's quite a lot because this is a place where there's a lot of startup entrepreneurs and programmers. And thinking about designing behavior for lighting and luminaires also means thinking about the dialogue between people and light. And for instance, going beyond the motion sensor, the light switch, and the dimmer that we typically use, and using software and graphical interface to expand our conversation. So in this case, the light sculpture broadcasts its own presence through Wi-Fi and lets anyone connect and play with a smartphone and with the smartphone sensors and gestures. The behavior installation emerges from the interaction between what the light offers and what the user discovers through the interface. So there are some simple buttons, as maybe you might expect, but there are also other ways to engage. For instance, using the sensors, so the accelerometers in the phone is one example, which might be a little bit more interesting maybe to discover, or using this sort of representation of shape and changing. So all this create different characters of light, different personalities of light. So this is where I think our work in creating algorithms and dealing with gestures, behavioral patterns, voice, artificial vision, sensing can make our interaction with building a lot more natural. Thank you.
Thank you. So that is something quite different of the maybe a kind of a future luminaire that we start to get light moving and swinging around a bit more. And now we have the provocations. I've invited two guests here to do the provocations, plus one person from Arup. First off, Dr. Jemima Unwin. Jemima is a program leader for the MSc in Light and Lighting at the UCL Barlett. Her background is architecture and qualified as an architect in 2005. Jemima recently completed her PhD studies in a research project in examining the impact of lighting on pedestrian flows in urban environment. As both a practitioner and researcher, her aim is to ensure a healthy and symbiotic relationship between practice and research. So I invite Jemima here. Thank you for your provocations.
So thanks for the invite to discuss two things I'm very passionate about. One is research and the other is AI. The role of research is to inform decision making, to improve the environment for all its users, and I believe that AI is an incredibly powerful tool for human good in all this. So I don't know if any of you, probably a few of you know who this chap is. This is Arthur Samuel. He was one of these computer guys. He'd written a program to play checkers, and he could beat his own program. He'd practiced, and he was getting bored one evening. He kept beating it. Then, so he thought, okay, I'm now going to set the computer against itself. So he got the computer playing against itself, and he added a line of code saying, I also want you to record the probability that one move will be a winning move based on all the games it's played by itself. So he went to bed, woke up in the morning, and by that time his own algorithm had beaten him at checkers before he was the best. So my first point here is that AI is dependent on enormous data sets, and this is now possible with cloud computing. And this is quite exciting because once you give everybody access to these platforms, you can democratize AI. And the quantities of data which can be examined are absolutely unparalleled. Although one challenge with research is quality of data, because we always have this issue, quality versus quantity. And typical lighting research, which is still going on, you have you're overjoyed to have more than 50 participants. You'll survey them, interview them, and typically going into depth to understand human problems. We've got to remember that humans are at the centre of this. And but then I was reading the other day that actually now an algorithm can understand the meaning of text. So that would have saved me 500 hours transcribing for my PhD, which is what I was doing, transcribing, reading it. So again, it has a role also in this quality of data, not only quantity. The other thing is that the research either has to generate you either need to generate the data yourself or access existing data sets. The other point I want to make is that about the definition of AI. So we have supervised machine learning, unsupervised machine learning, where you let the algorithm, you kind of tell it what to do and it works out how to do it. Then we have neural networks and then deep neural networks. So what that is kind of layers. It's supposed to work a bit like the brain. You have layers of data containing algorithms which interact with each other. like nodes, and then you have a reaction to that. And then a deep neural network is when this has a feedback loop. So a good example of that is autonomous vehicles. And what's interesting there, so my area of research, which recently has been outdoor lighting, is that actually now what are we researching for? Is it the sensors on the autonomous vehicles, which will perhaps be here in 10 years, or is it the driver's eye? And possibly the sensor for the vehicle is what it's for now, but then obviously you've got the humans involved looking at pedestrians, if how you light for a car changes, if it's the sensors rather than the driver's eyes, then that'll affect how humans behave too. So it also affects research areas for us. So I think this point about it relies on quantification. So if we think about people, we're complex and lots of things inform us, and we can measure things like activity, Fitbits, although there are ethical issues there with who owns that data. It's a company in America, and have we given them permission? So they've got to be mindful of this. So some things are quantifiable, and the algorithms definitely have a role in this, but then other things are a little bit more tricky, like, for example, ideas like kindness, which is, as you said, we need to set the values here, because you have many good research questions require empathy, and algorithms don't yet have empathy. So I will end by saying that as long as, it has a role to play in research and can be a tool for human good, as long as we remember that we're designing for people, and with collective opportunity comes responsibility for the ethical issues. Thank you.
Thank you, Jemima. And the next up is Iain Macrae. Iain is a chartered engineer and a fellow and past president of the Society of Light and Lighting. Iain graduated as a mechanical engineer and somehow found his way into lighting. Started with Thorn about 30 years ago and has gained many years of manufacturing application and technical experience on a whole range of projects. Iain now heads up his own consultancy on lighting strategy, design standards, technical marketing and training. And on top of all that, Iain also speaks on a wide range of lighting projects across the world. So I invite Iain to talk about manufacturing.
Thank you. That's a very old picture of me. The future of manufacturing, and I think I've come from 35 years of manufacturing experience, and if you've been in manufacturing, you might recognise this. I mean, we still employ tens, if not hundreds of thousands of people across the world manufacturing lighting by hand. You might believe it's all done by robots, but in the vast majority of cases, it's people putting wires into ballasts and into lamp holders or to LEDs and packaging it up, and actually keeps a lot of people gainfully employed. But there are some issues. Humans make mistakes. Basically, what you're getting here is what the manufacturer wants to make for you. The downlights above this wall that are lighting, actually quite interesting, a blue wall with wall wash, they're that shape and size because a manufacturer wants to make that and sell that to you. And that limits you to the choice of what's in the catalogue. Now, we'd have you believe that things have moved on dramatically. This is a local lighting company, and they make things by robots. And what's really lacking there is the people. It's been taken out of the manufacturing operation. But you're still getting a robot manufacturing exactly what the designer wanted to make as a luminaire. As a lighting designer, you have no real say of what shape or size or output or performance or distribution or colour or anything about that luminaire unless the manufacturer comes and asks you your opinion of what you need in the space. This is just automating, placing a ballast, wiring, putting the LED in the right place, putting the optic in, putting in a package. Now, you could argue that artificial intelligence might work out the quickest way to put the wire between ballast and LED. And over years of production, it could actually save you 10% on your wiring costs. But that's not really groundbreaking, is it? We know we can 3D print practically anything. Wow. I love the curve earlier because actually we're at that peak. We can print absolutely everything with some limitations. But it's now possible to print metals in shapes that you didn't imagine you could do before. Casting was a messy process. Printing is quite easy. It's possible to print onto flexible substrates so that now you can create electronic circuits that you can bend and twist. And in fact, if you believe the latest stuff, that solar panel up there is printed on paper. So you can actually at home print electronic circuit, and there's a good TED talk on this, might look it up later, where you can print onto a piece of paper a solar cell, and you can link it with paper printed cables to a battery that is also printed on the paper and can store charge. Admittedly, not very much charge at the moment, but it's possible. And you can print onto that same piece of paper an LED, so that when the sun goes in, the battery takes over and the LED lights up. And if you didn't believe it, that is a printed LED in the bottom corner. So it is entirely possible now to print a luminaire. Now that's not very sexy, is it? Because really what you're going to do is you're still going to get a downlight like this, printed on demand to the design that the manufacturer wants to produce. But if you take some of the talks we had earlier where you have great people who can imagine what the light can do within a space, and the AI can say, if I want a certain light pattern on this wall, it can back calculate to what that luminaire and that optic and that circuit could look like. And then you could hit a button, Giulio, and you can get out of the printer the luminaire that you want. That's provoking for the future. Thank you.
Thank you, Iain. Now I can count on you to think about the future of AI impacting our work. So the last provocation is by Inessa Demidova. Inessa is our architectural lighting designer working in a team in London. With a background in spatial design and critical thinking, her main interest is providing more meaningful lighting design serving people and places. What has changed? Inessa, please.
Hi, everybody. And so today, Florence asked me to talk about what's going to change in a way we design things. So maybe start with what is AI? So who here works with AI every day? How many people? Okay, so this is my day with AI. So I come to work and I listen to the music. AI tells me what to listen to. Then I go check my emails. AI sorts my emails for me because I just written some rules for it. Then I go for a meeting. AI tells me where to go, what to do, what to get, how long it's going to take me, definitely all my decisions. Then I calculate things. Imagine 20 years ago, I would not be able to be a lighting designer because I'm not technical. I failed at maths at school. And what formulas, what's Lumen method? And we wouldn't be able to even think about these things. Then I search for images and Google image search, and I say, I want to find a swimming pool lighting. And then I do my layouts, and I just say, like, yeah, how about like 2 millimeters between all of this? AI, give it to me. Then I do scripting in AutoCAD, because I don't know how to do scripting, I just run them. And then I listen to my really smart colleagues, to which are like, okay, now we can tell Revit to get everything from dialogues, and we just written the script, and that's AI as well. So AI comes really unexpectedly, and none of you may even realize when it comes in. It's all around you. So my AI wish list is based on one of my principles in life is do boring things faster and do fun things better. So I would want to say, what if we have AI there, which we could work with, which is one of our tools, one of our defining tools, but we not forget what we're designing for and what do we want to have. So at some point, I would want to say no to filling my timesheets and to filling schedules on Excel, to invoicing, to filling title blocks, to scrolling and searching for things forever and going through one downlight to another downlight to another in-ground, to extensive grid layouts, we just have a kilometer of the same thing. Why? To do background updates because the structure has changed slightly and they're using a different type of concrete, to filing my emails, to filing everything, to chasing suppliers. Thanks, guys. Could be better. Sometimes you're good. So, and I would like to say yes, and to have more time, to have meaningful play, to learn so much faster. Same goes to dialects. I can search, and AI tells me where to learn dialects, and I can learn dialects. Or I can teach our graduate to do dialects in 1 day instead of sending her for 3 months to school. We can tackle bigger tasks. We can ask questions we didn't even think about asking because we had to invoice, chase suppliers, and fill our timesheets. We can do very fast visualization because of the optimization of that. We can do better communication. We can probably stop solving the same problems over and over again and start solving new problems. We can have time to think things through instead of going on site and be like, okay. And we can continue using our senses because that's what we do the best. Computers don't have our senses, they don't have our environment, they're not in it. And we can have access to all scales to think on a global scale, to think on a scale of a city, on a scale of a street, on a scale of a building, of a room, of a human, on a scale of a single light switch, on a scale of a huge atrium of 20 stories tall. So when we ask about where is the value of lighting design and what are we thinking we're going to be doing, I hope we're not going to do any of the documentation, and our clients don't pay us for calculations, samples, schedules, or writing emails. They pay us for something which brings joy, which is awe-inspiring, which is fun to look at, and to think about things no one thought to think about. And that's my provocation, I guess.
That's why I've learned that I need to talk to my Gen X and what Gen Y and Gen Z, because you learn so much, you can imagine so much more. Right, panel discussion time. Can I just invite our speakers and our provocateurs to come to the front? So what kind of future do we really want as a lighting profession?
Shall I start? Okay. Well, I think the future that was sort of suggested in this last slide, I think I quite like. A future where, we can still be more creative, but creative on the right thing. So, but also a future where we recognize as society that we don't need to talk much about productivity, but more about happiness, I think. Yeah. So, well, yeah, that's an optimistic view, but yeah, whether it's going to be used in that way, yeah, I'm not sure. Who else wants to? Yeah.
I had one. We were discussing the other day something similar, and my take was that I want to have contrast. I would like to have very good and very bad, and I don't want to see everything the same. Everything like Google search of everything, because that will be boring.
It's customized to your, to what you want to see.
I think future people want jobs, so that's the key thing, that despite routine jobs and white-collar jobs being lost by development of algorithms, that still people have meaningful employment. Otherwise, as Elon Musk said, suicide rates will go up. So it's quite important that we all still have jobs.
I would say professionalism, because the risk of AI is that you can do all the mundane lighting design tasks very quickly, which means the contractor who still currently owns 80% of the market can just do mundane, boring buildings even more efficiently than they currently can. And what we need from AI is that fun and that awe and that enjoyment that puts good lighting back into the marketplace much better than we currently do it.
I want to see the future where people are more educated, where everything is kind of given to us and we're not caught up in all these mundane, boring tasks. So we can look around and we can see what is good, and we can see how we can do things better on every side of all the aspects of our life. So contractors wouldn't want a boring thing. So the researchers wouldn't have to transcribe 500 words. And just all of that combined together, I think that's what I want to see.
So as I said earlier, I just really want to spark a debate after a couple of talks and then the 3 provocations. So open to the floor. Any questions? I've got an Izzy's got a mic, a roving mic that he's going to pass to you.
Listening to you, I mean, one thing I thought of was how interesting it would be with future AI that it would truthfully, based on its database, be able to tell if something's interesting or really boring. And also, my main concern with the talk about relying on it is that as a professional in any business, use it, but you've got to have the knowledge to know if it's giving you the right answer, which means you have to be trained yourself. You can't rely on it because, well, that is not during the centre of the earth. It's the time machine. You know, the two different the civilization that didn't worry and was just happy all the time while they were being eaten.
Actually, I couldn't agree more. In fact, that's something we were discussing the other day when we had this sort of discussion. And basically, that's the problem, that if we get used to the machine doing everything for us, then we lose the skill to do it ourselves. We lose the ability to find mistakes, and then we can just say that, oh, that solution, I put together all this software, is so cool, it's so clever, but then maybe it's simply on the wrong basis, on the wrong background. And it's easy to spot now in research that has got some connection to ethics. For example, there was like a paper about sexual orientation and faces, the look of the people, and that's clearly wrong. You cannot do that. We know that, but that's wrong. We know it's wrong because we have a response which is ethic. But then if you ask somebody the lux level, that's no ethics. And so we would accept a machine because it's clever to do something, and perhaps we are using it in an appropriate way because we are not asking the right question. Maybe we could lose the understanding of the problem. So I think, yes, that, as you said, we need to retain critical thinking, absolutely.
Yeah. On this topic, we see a lot happening in terms of using these data sets on, I don't know, loans or maybe on legal cases to create sort of ways to screen people. And this is where I start finding some ethical issues to some extent, where human judgment can come with a lot of different things. And these algorithms are always designed in a certain way where they might be biased, as you said. So wherever there is an objective sort of recognition of a phenomenon, then it's easy to apply to some extent. Obviously, knowledge is important. But wherever there is a judgment to be made, then we really can't. Unless there is this artificial intelligence becomes superior in kind of understanding the nuances. Then it will always be something non-human. So, so that's where the risk is. And right now there is this big thing happening, which is proposing a lot of judgment and screening being made on this, and I find it very worrying.
I'd second the professionalism and understanding what you're doing. I think in the press at the moment, it was on the BBC last week, it's all over LinkedIn at the moment, light pollution, and LED, of course, is the big culprit. When in fact we know it's not LED, it's bad luminaire design, and it's bad luminaire application, it's bad optics, and so on. Now, if you took road lighting, there are a number of rules written around how you light a road. There are algorithms you can write to get the luminaires in the right place and to get the light onto the right place on the road based on our understanding of road lighting from about 1960, based for being able to see a cyclist on a road. Now, we haven't moved the standards and the calculations on fast enough, and if you now apply AI to that, what you get is really badly lit roads that we're actually getting at the moment anyway. The professionalism comes in to tune the AI to say what we need to recognize is there needs to be more research into what blue light does to the eye, how we see at different ages, the changes in road lighting use, and the AI should be able to learn that for us and give us better roads than we currently got. What I'd like to do is to see it give us better luminaires for lighting the roads in the right place as well on top of that. But if you just trust the computer to do the quick calculation, to take the boring stuff out, you will still end up with rubbish design if you put rubbish into it.
I would add probably to that, I feel strongly about it. It's like you get the answers based on the questions you're asking. And if you're asking questions to like, okay, how do I achieve 50 lakhs on this road throughout and throughout, you're going to get 50 lakhs on this road throughout, and that's not the right question to ask. So if we ask different questions to the AI, we're going to get different answers and continue trying to understand. But second part of my understanding is this over and over going argument that, oh, we're going to lose ability to understand what they're doing. But I don't know. I don't really know how to calculate light, to be honest. It's like I don't know what formulas Diallax is using. I know that Diallax is not right. I know that the formulas Diallax is using is still approximation. I just know that, okay, if we're going to put some strips there, it's going to be approximately that amount of light, but I can give you a number from Diallax. And that is not the value of lighting design. Probably the value of engineering, maybe?
I just want to sort of comment on, so far some of the responses about AI dealing with some of the more laborious, the kind of systemizing and standardization stuff. But what cannot be digitized or automated will be more valuable. So it's not just about understanding how to churn the right number out or not. It is what is really still most valuable, or even in the future, of our lighting profession is going to be. So it's really back to basic. What is it are we offering? Because AI, on the other sense, apart from augmenting and automating a lot of stuff, is also, it will be very easily available for laymen to be able to press a button and be able to calculate what light fixtures to be used and what light levels will be right for whatever mood they are or whatever their body clock is. It can be automated. So what is the remaining about our lighting profession? Wow, we've got a lot of hands up, but I know Peter's got a mic, so Peter, you can ask the question first.
Hello. One of the things that worries me about AI is, and you're already seeing it with house building before AI, you're getting 10 designs of houses being built all over Britain where they don't care what colour the bricks are, whether they fit in with everything else. There's no overall structure to the design. It's just cheap to make these 10 types of houses everywhere. And I think with AI, what could be worrying is you'll either get even more mass produce of the same thing, and you'll get two types of AI. You'll get the elite AI. If you're lighting a museum, you want to build a museum and make it have all the work that goes into it to make it a lovely space. And then there'll be everything else, which is very bland and very ordinary. So I think the question to ask society is, how can we structure society so that the middle of the road job uses AI in an innovative way and benefits people? That's my question.
Iain, would you like to take that?
I think there's a couple of interesting things there. That's a negative view of AI. What it's saying is AI will design down to the worst possible outcome, if we let it, yeah. And actually what I think AI could allow people, uneducated people, to do is to make decisions about their lifestyle, or in this case, their lighting, and be led to a solution that provides for their needs. So AI could be a way to open up lighting design to give us better solutions. What is the future of the lighting professional in that is, and where I think AI lacks is AI is not human. AI does not experience light in the same way as we do. We have 100 people in the room here, and everyone is seeing and experiencing the light in this room in a slightly different way, and AI can never predict that 100%. And so the lighting designer there is to challenge the way we look and we see and learn and be the human being, and to inform the less professional amongst us, the less educated amongst us, as to what that light will do to us as human beings. And that's where our specialty will come. And then to train the AI to do a great job with that human experience.
I'd like to invite Jemima to make a comment on, so how do we bring up and train our next generation of lighting designers to retain their human traits?
Yeah, I mean, I was just thinking about this as you were talking, and I think lighting quality is something which, the minute you can write an algorithm for it, it's no longer quality, because the whole point is that you're a human, you've got a client, they have their needs, you read the needs, and every site is bespoke, and you have to respond to your site and interpret it, and that's what makes a beautiful lighting design. And probably you could get, feed gazillions of images into an algorithm and decide what is beauty. But then it might not apply to another circumstance. So I think this kind of what lighting designers do, which is beautiful lighting designs, I don't think it'll ever be replaced by an algorithm, however cleverly it's programmed. And that your question was about kind of the mid-range stuff, I don't think you can do good quality with an algorithm, because that's the whole point. It's kind of rare. It's like if we had 1,000 Mona Lisas, it would no longer be special. so in a way, it's a bit elitist. I suppose design you could argue it's a bit elitist. It's the fact that we do see things creatively and differently is what makes it stand out. And if everybody had those skills, then it would no longer be design. And that's a bit controversial. It's a bit snobbish, actually.
Just I want to add a side track. I think I do really agree. But what about the standards then? Are they like a bad AI by definition?
Okay. So I've got a little app on my phone that is called Beauty Live, and I put an image of myself. And then obviously, I just show my age, very nicely. And then I can go, from a scale from 1 till 10. And then, you go 1 and start, something start to disappear. And the AI, my phone, starts maybe to remove the wrinkles. And, it adds a little bit more air on number 2, and then you go to 10 and it's a perfect model there. So you can imagine applying something like this. You just have your house or, you imagine your design. There is an app that the manufacturer gives, and you go on a scale, and then maybe you do an infinite amount of permutations, and you suddenly have your designs, and your designs are maybe customized to you. So in a way, there are ways which can be very, very, can be created with algorithms, with ways that maybe personalize more on what people think. And that can create more happiness to some extent and more designs there. So, where is our role there? Maybe someone will build it and will make a lot of money. Yeah, maybe I've given already an idea to some around us. But that's the reality. The fact that automation can be used creatively is on one side, and automation can still create interesting experiences. In this particular case, it's something for fun, but it is happening right now. It is making a lot of those maybe repetitive tasks disappear, but it is also making, I think, interesting things happen, and which maybe we didn't think about. So there are opportunities as well. So maybe think about both. Yeah.
Okay.
Could I? So I would say I probably would want to disagree with Peter. I would really, really, really want to disagree with Peter. To me, like mediocre AI and elite AI is quite dystopian, but also not what I see in the world. And to me, maybe the AI will allow us to have every lighting space to have the level of attention and a level of detail as in a museum. But then what do? We get really bored, so we're just going to find something else. And as I said, we're just really good at sensing. We're really good at talking to somebody who I wouldn't speak to necessarily. I go for coffee, I speak to my friend who is a data scientist and a DJ by night. My designs will never be the same as predicted by AI. And we're really good also at connecting to each other, and technology allows us to be better connected to each other. So how about we, instead of thinking that they're going to be like a mediocre lighting design because of AI, and then rich people will be able to afford elite AI, I would rather imagine that AI will be affordable by everyone because computation is cheap, at least at the moment, with current technological progress. And we will be able to have something better, because looking out at lighting design, there's so much more better things to do. On every single room I was like, okay, this could be done better.
Do you think the house builders will allow people that choice?
If it's cheap, why not?
Helen's got the mic, so maybe Helen asks the next question.
Can I just answer quickly?
Yeah.
I think one of the questions was how do we train our future lighting designers based on AI can do the fundamental tasks? And it goes, that hasn't changed in the last 35 years. you don't get a good designer by teaching them the Lumen method. Forgive me, I know the Lumen method. It doesn't make me a great designer. It means I know the Lumen method. What makes you a great designer is to go out and play with light and experience it and make mistakes and learn. What worries me about AI is if that learning process becomes part of a computer and not part of a human experience. I don't think it will become, because we have 100 people in the room here, and if we all got out our iPhones, or sorry, other phones do exist, and looked at your music tastes, they would all be different. Every human's idea of what is beautiful is different, and that's where the lighting designer will come in, and we will continue to create great lighting designers because they will have their own interpretation of beauty that other people will see and go, my goodness, that's what I want. And the lighting designers will be the leaders in the industry who have that vision, like the Monets and the Picassos, who at the time were not painting great paintings. It was only years afterwards someone went, and I really love that.
Thank you, Ian. I'd like to let Helen ask her questions. Yes, put over your mic.
I, interestingly, was listening to a radio programme last week, and they were saying that once the artificial intelligence starts to get as intelligent as us and can write its own algorithms, it will very quickly become super intelligent. So as you were saying with the checkers game, they very quickly learnt to beat the guy that was writing the programme. So at some, if you take that to its logical conclusion, we will be, our lives will be governed by a higher intelligence. And we have experienced this in the past because we were all children and we all had parents who were this higher intelligent being that looked after the mundane things and allowed us to play. So this comes back to Inessa's vision of the future, where we can all play and enjoy ourselves. I don't think we will be working. I think that will all be taken care of. So now we can say, what lighting do I want to experience my particular game? And you tell the AI, and it just does it for you. So it's, and yes, we are all different, and we will all want something different, but it will be possible for us all to have something different. And we won't need those standards because it won't matter what the street light's like, because we've got electric cars and they don't need lighting. So if you take it further down the line, things will change beyond our comprehension. What worries me is, when do we stop even being part of all of this? When do our thoughts, our imagination, what we find beautiful, when does that stop being an integral part of this? And that's possibly what Peter's saying. If we allow it to all be mundane and the same, our input will stop. If we can have it reacting to what we want, we can all have our individual taste in houses, and the artificial intelligence can then create it. So how do we make sure that in the future, as all this process is happening and all those algorithms always have us as the prime focus, or at least our planet, rather than allowing the AI to make its own decisions?
Can I answer? I just read an article about that yesterday, so I'm really excited to disagree with you. And this idea about the intelligence explosion, so what really blew my mind there is the realization that it's not that the super intelligence will have to overcome an intelligence of like any single being, be so Einstein or Florence. She's really smart. But I think it's more about that we think about the fact that we are not intelligent. Every single of us is not intelligent. Every single of us is basing our intelligence on the bigger intelligence, and the more we progress, the better we manage to build on each other's intelligence. So how would AI, even however much connected, be going and try to catch up with that? So to me, it's more of a sense of combination, which will bring better something. And your idea of kind of like giving up to intelligence is something I don't think we will ever do, and I don't think it's going to bring us anywhere nice. There are always going to be people who would want to tinker. There are always going to be people who would want to make something different. There are always going to be people who want to disagree with the algorithm. Like, I don't want to say, oh, make me pretty. I want to say, just make it more interesting and make it the way I want it, but show me how exactly it's done. And we'll be able to specialize in certain parts. So if I want to say, make me all the materials pretty, but lighting, I always want to get a sense of control on every single detail, and maybe I don't want to repeat it a million times. But if I will give it up to AI, I would say it's probably a really bad future. And the second part of it is the requirements to make the superintelligence happen are exponential. And that's something I still need a bit of time to process. But the idea is that the progress is linear, but the requirements for resources are exponential. So the progress is likely to be linear, and we're likely to be working together with AI. Because, I mean, just working here, you see people who never, ever agree with what computers tell us to do. And we rely on them heavily. Like, Arup is one of the first companies who actually used computers in construction. But we always disagree with them.
So
Got another question there?
I would like to add some. So the topic is super interesting, and I think your radio sort of program was similar to an article that Santiago Torres over there sent me like a few months ago, I think, and it was really about this point of the singularity when AI becomes like superhuman, and is it going to be a good god or a bad god? I mean, type of thing. And that's, it's far. It's not yet there. What I want to say, I think we can stay positive because, first of all, we have got standards. So I was joking before, probably nobody realized what I just said. Standard is like a monster. It tells you what to do. If you follow the lighting standard, we are like good or bad, they are a bit dodgy sometimes. The designs are not necessarily great.
We ought to point out that we both work on the same standard.
Yes. And we agree on this, I suppose, which is good. So we have a mandatory sort of thing that tells us what to do, and we don't do it. Thanks. Thank you, everybody. So it means that we still are, subjective. We like the way we like. The client prefers something a bit more than the standard and so on. And so we survive this sort of machine, which is the standard, which is an algorithm. Like you follow the rules and you deliver a product. Like pop, 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 pop. That's easy to automate, but we don't do it. And then why we don't do it? Because nobody wants that. So that is one item I think interesting to discuss. The second one is that, of course, we can, what I said originally, we can enhance what we do. Like at the moment, like all these statistics, like supervised learning, unsupervised clustering learning, and so on, they're extremely useful in what we do. They are not like the solution to the problem, but they are a tool. Something you use, you apply, you get a good solution. You have to smudge it, you have to adjust it to your particular needs. So there is a lot that can be done. It's not just the solution. And it's definitely not a scary monster because the standards are much more scarier monsters and nobody actually is hurt typically, so it's okay.
Could I ask a question?
Yep. Yes, please.
Really, one of the opposing sides to that is, are these machines ever going to be able to apply for their own professional indemnity insurance?
I applied for professional indemnity insurance the other day, and lighting design does not exist as a trade as insurers understand it. And you know where they get their information from? Artificial intelligence.
Well, they will not need to pay for that because it's all statistics, so it will be not required. It's just like, if the percentage of success is good, why would you spend money? Maybe it's like 1 every 1,000 problems, it doesn't cost anything.
I think going back to, it's a bit of a jokey statement, isn't it? But artificial intelligence in a very simple form has been on certain manufacturers' websites for a number of years. And if you go to the right manufacturer's website, it will tell you how many luminaires you need in a room based on statistics and numbers that were done 20, 30 years ago. The clever bit of being human is being able to read what that computer tells you and work out it's complete rubbish. And luckily he's not in the room, but there is a sales guy who I worked with a couple of years ago who accepted the numbers being crunched by the computer that 11 fittings in 2 rows was a sensible project layout when the length of the row went across the shortest width of the room. And he was quite happy to accept it because the computer was right. And that's where you need professionals. That's where you need people to understand that, yeah, AI can be fantastic, but if it really develops to the point that it is superhuman, and super intelligent, but still churns out complete rubbish from a human point of view, then that's where the designer will come in and stop that. Well, and you do know about it. I mean, you sit in your lounge every evening and you play with the lighting. Well, perhaps only you, because you have the best lounge in the world and the best lighting scheme. But imagine now, as a homeowner, you can tell the room what you want it to feel like, because you as a human know that putting light on the walls will feel better than putting light on the ceiling, because that's the mood I'm in. The artificial intelligence can perhaps tell the lighting system how to create that in the best and most efficient way.
I think Stephen's got the mic, so Stephen's asking
sorry,
questions.
another question. Just a question, we're talking about design and lighting design with AI, isn't it a really good opportunity over the life of the installation that lighting now becomes dynamic, and even the installations become dynamic? So surely that is an opportunity for lighting designers to own the space, manage the space over time, and change the use of those spaces.
Yeah, I think that's one of the best points. Yeah, so it's all about creating better user experiences, I think, creating a system that are more adaptable as well. And obviously we've got already, we already started seeing some of this interaction emerging, and behind that there is this wealth of computation and network that is making these systems possible. So the fact that you can talk now to a luminaire, because yeah, it is something that maybe we were imagining in movies, few decades ago, and now it's possible to do, relatively easily. But I would say most of these components that are now available, the typically called cognitive services, if you apply to a cloud platform, you can pick them up and combine them, with a little bit of, obviously, of coding skills, but to some extent they really allow to think better, not just about the design part, but also about actually the longevity of a project, which might be designed in a few years' time, or even in a few months' time, but then lives for a lot longer. And that's where some of this technology can really make a difference. So adaptability, I think, is one of these aspects that we need to consider. So when we design spaces which can, to some extent, behave, understand how they're occupied, and adapt, creating maybe more optimal energy situations, but still not compromising the visual qualities, as an example. Yeah.
Yes, sorry. Provocateurs, I haven't heard anything about artificial intelligence here tonight. What you've spoken about is massive data processing, which is something a computer does very well. In my day, it was a slide rule. I was interested to hear that you're still concerned about designing for people, which is something we were doing 60 years ago, and we don't seem to have really progressed in that field at all. And I don't think artificial intelligence, as you're describing it, will actually do that. I think what you've got to think about is that artificial intelligence must be something that is thinking, something that is going to, you ask it a question and it will come up with an answer. What you've been describing doesn't do that. So I don't think your premise is right.
So we have a system upstairs that recognizes faces. So that one is a trained system, and you ask who this guy is, and it will come up with a judgment. Well, it's with a score, let's say, onto a recognition. So that's
not lighting design.
No. But what I mean is an example of applying a system that can use a neural network.
Yeah, but we're not talking about that. We're talking about how artificial intelligence is going to affect the lighting designer. So facial recognition might be very good, and artificial intelligence, but it's not lighting design.
Okay, Bob, like our computer is still the same since you were here, so our chances to do some big work is not so good. But anyway, no, I think Yes, it's possible. So if you imagine, for example, you take all the pictures that you can possibly take for an auditorium, and you make a mega average, and then you can use, similar to image recognition, the same system. You can say, okay, I want an auditorium. How should it look like? And then plop, you get the average picture. And that can adjust based on your preference. You click, I like, I don't like, I like, I don't like. And then by the 200th auditorium you design, the machine will just suggest you the best one, as when you rent a movie online. That is something that is fairly possible. But is that enough? What you want, and I understand, is the next step where you actually interact with the machine. You ask a question speaking, and then the machine will answer by talking or by sketching something. For that, you need several layers of this intelligence, which are generally only provided one by one. So on the phone, you can ask a question and we'll answer a little bit silly answer, but it's never like the double deep answer that you're looking for. It's just like a preliminary, answer to a simple question. I think it will take a long time, definitely. It's not like so ready as in the movies.
It's already gone fast.
Yeah. The thing is that if you...
I think you are probably pretty much spot on with what I was trying to get to here, is if we look at a lot of the day-to-day stuff or work that we do as a lighting designer, a lot of people do believe that knowing how to run dialogues or do a bit of visualization, Photoshop, that's lighting design. But it is not. Those are just easily automated and digitized in the future. It's getting back to the fundamental of what, Bob, you would imagine that could be. Can I just ask you to feed it back? So imagine in the ideal world, the AI will really take over. All the stuff that you've done is just felt that it's repetitive and so on. What would you think is the fundamental of the lighting profession? Give him the mic. Give him the mic.
You can do away with the mundane. But that's something that a computer does very well. What you'll do by that is you'll increase the number of unemployed, and I think human interaction doing those so-called boring jobs is a very important thing. I think also that if you're not careful with artificial intelligence doing the thinking, you will end up with a whole load of boring designs because the machine's doing it, and you're back to not having that human imagination. It's going to be a long time before you get to the point, I think, where artificial intelligence is doing that sort of thinking. If you go back to the 60s, Jack Waldron suggested a design method called the Luminance design method, which started by looking at the space and deciding how the space should appear. It fell down because the calculations in those days, and we're talking when you had slide rules, not computers to help you, it fell down because it was so difficult to calculate back to find out how much raw lumens you needed and what the distribution was going to be. But in a sense, that's what you could do now.
Yes.
But it's data processing. It's not artificial intelligence.
Well, I mean, what is not that is a brain like with the cables. It's just a statistical, as we kind of hinted. It's a big statistics. You provide data, and then you get an answer that approximates your preference based on what I know about you. So I need a lot of data. And one of the funny things is that we always think about, oh yes, we can train the machines, but if to show a picture and get the machine to recognize it, if you use a pre-trained network, which has been already trained and is already able to recognize pictures, you only need a few examples. But if you start from scratch, you need thousands, millions of pictures. So you need millions of designs, or even more, in order for a machine to be able to recreate a new design in a sensible way. So I don't think that there is any lighting designer that I know of that has got 1 million project. I mean, perhaps we hope for, but it's a long way to go. So it will be taking some time to train, for sure.
The other aspect is that we're talking about narrow intelligence, so we're not talking about the super duper intelligence that is flexible and can adapt to everything. So it is a system that can learn from a huge data set and can respond a specific question. This is the type of intelligence we have right now, and that's the one that we can use as a tool.
Any other contributions before I wrap up? Is it past 8 o'clock now?
Okay, So probably a quick thing. I think, Bob, it's just that you were really ahead of your time. And you know how they say the future is already here, just not evenly distributed. So you were thinking about things which take a long time. And the computation definitely helps us. I'm looking at architecture a lot at the moment and seeing what, like how a day of an architect looked like before. Now it's just so much faster. And I'm seeing some architects doing things nobody else could think about for the last, 30 years or so, just because of computers. And, imagine if you had to spend 2 days drawing a section, and now you can draw a whole house. And the same for us. I think freeing up this time, we can either do it by freeing up the time and do 10 projects of the same quality in the same time, or we can do these 10 projects, make money, and then spend more time thinking about what else we could do better. But I don't think we'll be relying on computers answering our questions. So we'll be probably relying on computers understanding us better and understanding what we want better. Same as image search, but advanced.
Yes, of course.
Yeah, but what
Bob,
do you want?
Can I say one thing?
It's a really narrow intelligence. It is intelligence,
Yeah.
but it's narrow.
Okay, I think...
no, just one quick
more,
one,
okay.
very, very tiny, very tiny. Even if the machine looks intelligent, even if the understanding of the machine may be different from ours. So if you go upstairs in the exhibition, there is a sort of abstract sort of diagram which was prepared by Santiago Torres and Vincent Kahn, who are over there. And that diagram shows you what the machine thinks is a traffic light, which doesn't look like. It's a completely random pattern. And the machine thinks, oh, it's a traffic light, because the linear system that is used to process the picture as a vector and so on has infinite solution from a mathematical point of view. So you can supply the machine a completely random sequence of pixels, and the machine will tell you, oh, it's a traffic light. But we human can tell it's not. So yes, it's very narrow intelligence. And at this stage, I think there is a lot to do for it.
But do we want it?
I don't know.
Can I just say one thing? And then perhaps drinks upstairs. Intelligence, as we know it as human beings, we can make decisions. And that's what we call intelligence. We can envisage the space around us, use all the senses within our human bodies, and make a decision on the information we're receiving. A computer is just doing the same thing. It's not. We're not waiting for some God moment where the computer suddenly does something fantastic that is not human. They will do the things that we do. They will read from senses. They will take information, they will process it, and they will make decisions based on it. And that's what artificial intelligence will do. What we have to do as human beings is teach that computer to make better and more accurate decisions than we as humans will do. And the advantage of AI will be that the information that's inside 100 people in this room can be in one computer and give us better decisions than one person on their own. And AI will be able to take the information from lighting designers from across the globe and apply it, rather than us having to spend 35 years learning it before we get to the point we can call ourselves professional. So it's not some massive step. It's just replicating what we do. And my worry is actually, what will we do when it gets that good?
Okay, I think I'll wrap up now because there are drinks and food upstairs, and I'm hopeful that the debate will keep going. Just one thing I want to say is technology. I really believe the technology is about how the change is going to happen. But the humans is really the why. As long as we can still be creative, still be imaginative, and have that sort of gut feel, we will be able to ask the right questions, and that's what sort of shape, whether it's a wardroom, light painting, ideas, or something else. Bob, in 2 years' time, I think we have an automated process that can transfer the wardroom, light painting into something, a delivery spec sheet.
I love the event. It was a great discussion and some really obtuse ideas, from people that really know their stuff.
It brings attention to a current and exciting issue which built environment is probably, feels quite behind compared to other industries.
I don't think that AI is a threat to lighting designers, but I think lighting designers think it's a threat.
I think we'll see changes. And those changes might be good, actually, in some ways. I think we might see a much more collaborative approach.
It's not exactly a threat to lighting designers who still want to explore new things and ask different questions to what AI could ever come up with.
I think AI, it can enhance the experience that we can create.
AI offers the opportunity to create solutions very quickly, test things out, see how they look, but you still need that human interaction.
Because no client wants to talk to a robot. They want to talk to a person and engage with someone who will make it fun and interesting for them.